All right, I left magnification for its own video because I was like 15 minutes into the other video and I knew I made a mistake in the equation. The equation for magnification is HI to HO equals negative DI to DO. So that I had the negative sign on the wrong side, which mathematically is okay, but it leads to confusion when trying to calculate these magnifications. Okay, so it should be magnification is HI to HO equals negative DI to DO. We classify heights as being negative when they're inverted. So if you look at the green arrows in this concave mirror here, I have a positive HO because you always make the object height positive. Whatever its orientation, you call that the positive direction. And it's a negative HI because it is an inverted image. When you do this formula, you are going to get a negative magnification implying a real or inverted image. When you look at the red arrows, your HO is positive because it always is. Your HI is positive because it's an upright image. So when you do this equation, no matter what the sizes are, you're going to get a positive M, and that positive M is going to imply a virtual image. Okay, so this is just the M's I'm looking at now. Now, let's just do the convex mirror quick. Magnification is HI to HO, and they're both of the same orientation, the object and the image. So I'm going to get a positive M out of this, once again, because I have a virtual image. So when your object and your image are both pointing the same direction, you make them both positive, your magnification will come out to be positive, because the only way your object and image can be pointing the same way relative to the principal axis is if you have a virtual image. But as we see in the first diagram in green, when you get a real, which is always inverted image, your magnification should come out to be negative. Now, looking at the equation for distances, I've only done heights in this, or sizes. With distances, we are going to make DI positive for a real image. So if you look at this green one again, maybe what I should do is erase all of the H. I kind of want to leave it so you can see it, but it's going to make things a little uglier. DO is positive because DO is positive for a real image. For all objects, excuse me. I'm sorry, I'm thinking ahead. DI, the image distance, is going to be positive because we make real images have a positive image distance. And you're going to find that when you do M equals negative DI to DO, that's going to come out to be negative because, once again, it's a real image. So you can do this with HIs or HOs, but you need a negative sign on the D side to make the M sign come out to be correct. With this virtual image, you make DI negative for virtual images. So when you do M is negative DO, that's going to come out to be negative a negative DI, which is going to make the whole thing be positive. And a positive M, once again, will mean a virtual image. Same thing here. That DO object distance should be plugged in as positive because they always are, but this is a virtual image, so you plug the DI in as a negative value, and when you do this, it's once you're going to be minus a negative number, which will come out to be a positive magnification for a virtual image. So there's the sign, and this whole page is only about the sign of M. Okay, the sign of M is positive for upright and virtual. It's negative anytime you have an inverted or real image. I kind of want to pause so you don't see me do magic. So now I want you to look at the size of the magnification. Again, magnification is still HI over HO equals negative DI to DO, but the value you can get can be greater than, less than, or equal to positive or negative 1. So if the absolute value of the magnification is larger than 1, the image is larger than the object. If the magnification's absolute value is equal to 1, they're the same size, and if it's less than 1, the image is smaller. So let's just put objects in here. If the object is located in these positions, what will the image be? Well, if the object is located here, beyond C, Now I'm going to tie the two slides together. I'm going to give you sign and greater than or less than a 1. So I'm going to make up numbers like 1.5 or 1 or 0.5. So a magnification, when the object is located beyond the center of curvature, well, I'm going to get a real image. So the M should be negative. And it's going to be smaller than the object. So it might be something like negative 0.5. And I'm making up the 0.5. The actual value is going to depend on the ratio of HI to HO or DI to DO. So that's what the magnification might be out here when the object is located beyond the center of curvature. Well, what about when it's located at the center of curvature? Well, the image is going to be real, so it's going to be negative, and it's going to be the same size. So when the object's located at C, the magnification will come out to be negative 1. When the object is located between C and F, you still get a real image, but that real image is going to be larger than the object. So it might be something like negative 2. Again, it's going to depend on where you've got the object located, DO, DI. And then lastly, if your object is located between F and the mirror, you're going to get a virtual image. So this magnification is positive, and this is a makeup mirror where the image is always larger. So this might be something like positive 2. There is no way to get a magnification of positive 0.5 because there's no positive image that is smaller with a concave mirror, and there's no way to get a magnification that's positive 1 because there's no magnification, no way to do this. There's no way to use a concave mirror and get an image that's the same size as the object. You only get images with a concave mirror that are larger. You might have to go back and look at other videos and draw diagrams to see that. So there are all your possible magnifications based on where do you have it, beyond C, at C, between C and F, or between F and the mirror. Those are all your possible magnifications. Again, I made up the magnitude of the number to be 2 or 0.5. The important thing is it greater than 1, less than 1, or equal to 1? And then positive or negative. Okay, what kind of images do you get with the convex mirror? Convex mirrors always give you positive images that are smaller than the object. And you cannot get, with this type of mirror, a magnification that's equal to positive 1. You cannot get a magnification that is greater than 1. And you cannot get a magnification that is in any way negative, because you can't get real images and you don't get virtual images that are larger or the same size. I don't know that I would in any way memorize the what you can't get thing, but if you look at it and try to figure it out, hopefully it'll make sense. And if you do the if I do, I die equations and come up with your DI and DOs, you'll be able to plug in and get these things without a problem. There's an awful lot of stuff to remember, but boy, as far as things go, this is a lot easier to grasp than a lot of other things we've done this year. So you probably want to, I would think you'd want to hope for a curved mirror, curved lens, but I'll tell you, the kids that get 3s on the exam every year don't want these because they haven't worked as hard to memorize what all the different values of M and H's and D's can be. Have a good day.